in early 2000, 2004, 2005. Then within 2-3 years came the deep learning ideas. That means the neural network having lots of hidden layers, enormous number of hidden layers that allowed us to do many of the real-time application development of speech recognizers, object recognitions, what do you call driverless driving, I mean the driverless car. All these were made possible due to the development in the deep learning area. So this is the connection. I hope you must have already discussed this. The artificial intelligence area, the ability of a machine to imitate human intelligence. So that was the long-term goal for the researchers and scientists working in this area. A machine can do anything, any intelligent decision like a human being. So that was the whole idea. And as I said, rule-based and later the machine learning algorithms. Machine learnings are actually, it is a set of algorithms. Now we are living in an era of AI boom. Okay. So today, after some introductory notes, we will be looking at some of the regression examples, basically the linear regression and polynomial regression. And then we'll move on to the classification, and most of my focus will be in supervised learning models such as k-nearest neighbor, linear discriminant function, logic regression, decision trees, support vector machines, and ensemble learning. As you know, there are too many topics. We will not be going to the depth. Term improves performance from experience. As and when you go and see different variabilities, you learn to understand it better. You learn it better. Okay. So the same idea we are incorporating to the machines. When I say machines, it can be a full-fledged computer or it can be a specific processor which is designed for a particular application, like in embedded systems. Okay. For example, if you take a human perception, human vision, assume that you are driving your car. So I am trying to, morning I was coming this side, so I was trying to overtake a vehicle in the 2-lane road. Then suddenly I saw another vehicle coming in that lane. Then I decided not to. So that decision was taken by observation. I was looking at the other lane before attempting any overtaking. Then I saw this vehicle, then decided not to. So it was like seeing, processing, then take an intelligent decision. So the same thing we try to incorporate in computer vision, where you have a camera for acquiring the image, then you have to do the processing. For example, in my case, while driving, I was looking, my decision was entirely based on the vehicle that was coming in the other lane. So I need to basically look at that vehicle alone. So I'll do some segmentation. I will get rid of the background information. I will look at only the vehicle that is approaching in the other direction. Then it will be given, that pattern will be given to the pattern recognition system. So pattern recognition is another word for, another bigger, concept for machine learning, where patterns are recognized using machine learning techniques. So pattern recognition is one way we discuss the machine learning, because the modeling is done with the help of machine learning. Patterns are recognized using machine learning techniques. Okay. What exactly discriminate an apple from the other objects? Those are features. Some discriminative ability should be there for a feature, so that you can discriminate between apple and other objects in this set. So we have to find out the feature and find the appropriate feature. And then using those features along with the training labels, you can learn a machine learning classifier. So the classifier will be mostly a machine learning classifier. And so what do you mean by feature? So these are all examples to give you an idea. Okay. So what is shown here is, I have two fruits. Basically, oranges and lemons, and in this case just the dimensionality may be good enough for classifying these two, that is width and height of the fruit. If we can measure the width and height of the fruit, based on that you will be able to classify whether it is a orange or a lemon. Okay, this lemon is not the small lemons, okay, big lemons, okay, as it is shown in the figure. So if you are taking width and height as the feature, so now this is a feature because it has a discriminating capability. Okay, so this is called a feature, and this is not just one or two feature, you can find any number of features. Okay, so in this case you can see that based on the width and height of oranges, they are all marked as red dots, and lemons are marked with blue. Okay, blue rectangles. So you can see that, and you can see that there are some commonality if you look at the red dots versus the blue rectangles. And if this is not good enough, probably you can think about adding some more features like the texture. Texture of orange and lemon will be different, and the color may be different. Okay, for the ripe ones the color may be different. So you can include any number of features. So feature, identifying feature and selecting the appropriate feature is very important. So the first one is known as feature extraction, and the second part is known as feature selection. You need to select appropriate features so that your classification performs very well. Okay, does a classifier performs a good job. So each point in the feature space, each data point in the feature space is a sample for us. So these marked dots and rectangles are samples, and they are represented as points in the feature space. Okay, I hope this is clear. Look at the other case. They are all mixed. Can you draw a line, or can you draw any difficult boundary? It is not possible. So the choice of features is very important in doing solving any classification problem. So that may be a good compromise, because if you look for a very complicated boundary, then your machine learning algorithm will be too complex. Plus, there is something called overfitting. Especially in real world scenario, these data samples will be noisy. There can be noise or outliers. Okay, and if you look for a overfitting, then that may lead to too specific, so it will lack generalization. So it may fail when you actually deal with a test. So for the training it works very well. As you can see that training, the black curve, the training error reduces as you go on further and further. Your decision boundary is becoming complex, your training error is becoming low, and if you test it with the training example, it will give a perfect classification. But when you expose it, when you use it for testing of unknown examples, then it will not perform well. Mainly because this noisy data samples actually biases your model. So always we look for a compromise between this underfitting as well as overfitting. So these are some of the general aspects in machine learning. Pattern classifier. Pattern classifier is a machine learning algorithm. Okay, that is the connection between this PR and ML. Okay, so classifier in this case will be a machine learning algorithm, and always you will evaluate the performance of your model, and your feedback will be given back to all the system for improving the performance of individual blocks. Now these are how the classification and the regression are being done graphically. This is illustrated. In classification, this is a simple two-class problem, binary class problem. All the cross blue lined area, they belong to one class, and the red circles belong to the other class, and you can have a boundary by which you can say a new data point is coming here, you will immediately say it belongs to the red circle class. Okay, so that is the classification. So you are predicting the label of a given data point. So in case of discriminative classifier, you are able to discriminate even without knowing the system. Even without knowing the languages, you are able to discriminate between Tamil, Telugu, Malayalam, Hindi, all those languages. You won't be able to speak. But in generative classification, you will be able to construct sentences. Only then you will be able to differentiate. I have a very good knowledge of Malayalam, I have a very good knowledge of Hindi, then I will be able to find out whether this is a Malayalam sentence or an English sentence. So this is how you actually classify, how you actually differentiate between these two, generative and discriminative models. Okay, so this k nearest neighbor is based on that aspect. You look at k neighbors. Neighbors in the sense, when you come to this classification, the points, our neighbors are points, nearby feature points. You look at the nearby feature points and see their label. If your neighbors are bureaucrats, then you will also be classified as a bureaucrat. If you are near to a criminal-minded society, then you will be classified as a criminal. So basically, look at k neighbors. K need not be 1. K will be more than 1 in a practical k nearest neighbor case. You will look at k nearest neighbors and see which classes they belong. Okay. So here actually this, you can see that the margin is located, they are identified by finding this data points near to this discriminant function. Similarly, this side, this is the point which is actually lying on the margin. So margin do not have any data points. Basically, you have you are looking for a discriminant function as well as a good margin between the classes. Non-linear side, suppose your data points are non-linearly, they are not linearly separable like this. This is your original data points and you have two classes and only a circle. In this case, I have drawn a circle to divide the two classes. Circle is a very complex decision boundary. So therefore, how to do in such cases, how to create a boundary in such cases. So what there is a theorem called Cover's theorem. Cover's theorem states that if you can transform, you can map these low dimensional feature points non-linearly to a high dimensional feature space, then probably you will be able to separate it using a hyperplane. Why we call it as hyperplane is because it is higher dimensional. Okay, so you are making a non-separable low dimensional feature points to a linearly separable higher dimensional feature space. Okay, this is the idea of non-linear support vector machines. Okay.
I learned many things from this and it may helpful for our project. I am doing speech emotion recognition project now. So it's very helpful for me and then we learn enjoy also. It's make interesting something too. And then once upon one more thing I want to say, how to atmosphere explored, feel good light. That map teaching well, smooth and cool. Its may appearance is very beautiful, and then that's it. Thank you to all. Thank you, ma'am.